Good day, Captain Philip Aynalquino, to our classmates, and to everyone who could be viewing this right now. My name is Decadent Baginjan Dave, and alongside me are my groupmates, Decadent Dave Antonio Boliosos, Decadent Francis Rigi Bungoyan, and Decadent Manuel Earl Buenafe. So today we are going to discuss about compass navigation, and without further ado, let us begin. So in here we are in our week 2, session 2 of our midterm period, and our topic for today is about magnetic deviation. As you can remember with the previous group discussion of the group 1, they had discussed about the compass, its basics, its nature, and about magnetic variation. In here, are going to talk about magnetic deviation and how to correct both magnetic deviation and variation. So let's begin. The course outcome. So to be able to learn about compass corrections to determine true course and true bearing. The learning outcome. So by the end of this session, the students shall be able to correct both deviation and variation and convert compass course to true course. Lastly is the importance of the topic, which is the about the compass error should be checked on each watch and on every new course to measure the error of the gyro compass, which is the angle the gyro north makes with the true north to establish trends in deviation on different courses at varying latitudes. It is important to the students to have a working knowledge on how to correct the compass to become a future navigator on board. So first, magnetic deviation. Magnetic deviation is the second commonly correctable error, this time within the ship, which is caused by magnetic forces brought on by pieces of metal such as the engine or the anchor. Moreover, cockpit platters and electric or other electrical equipment or wirings, if too close to the compass, can also introduce a compass error. So in here we have a chart. So pertinently, the deviation varies with the ship's heading. So the angle of the yacht's center line with the true north, resulting in a deviation as shown below. So in here, the vertical axis states the correct deviation in degrees west or east, where east is again positive. So the horizontal axis states that the ship's heading, or the compass course, in degrees divided by 10. Thus, when steering a compass course of 220 degrees, the deviation will be 4 degrees west. So in here, you should check the table every now and then by placing the yacht in the line of a pair of leading lights and turning her 360 degrees, a time-honored method known as swinging the compass. So conversely, a handheld compass does not have a deviation table. So ideally, bearings should be taken as far from metal and electrical wiring as possible. For the following slides will be discussed by Decadet Manuel Earl Buenafe.
Thank you for that, Cadet Bagin. So for the correcting for both deviation and variation, let us remember that converting a compass course into a true course, we can still use our equation, but we need to add the correction for deviation. So what is the formula? Compass course, or CC, plus variation plus deviation is equal to TC, or the true course. So here we have example 1. We sail a compass course of 330 degrees with a corresponding deviation of 3 degrees. And from the nautical chart, we find that our location has a variation of 3 degrees. So from the given, we have here the compass course of 330 degrees, variation which is 3 degrees, and a deviation of 3 degrees. So by following the formula, 330 degrees plus 3 degrees plus 3 degrees of the deviation is equal to the true course, which we're going to have the true course of 336 degrees. Next, please. Example number 2. We change our compass course to 220 degrees. The deviation is negative 4 degrees basing from the table, and the variation is still 3 degrees basing from the chart. So here we need to follow the formula. From the problem, example 2, We have here 220 degrees as our compass course, variation is equal to 3 degrees, and deviation is equal to negative 4 degrees. So 220 degrees plus 3 degrees of variation and minus the 4 degrees of deviation is equal to 219 true course. For example 3, after sailing extensively, our compass course is still 220 degrees. Therefore, the deviation is still negative 4 based from the table, but since we are at a new location, the nautical chart specify a variation of negative 10 degrees. So in example 3, we can see that our compass course is still 220 degrees, and our variation changed a little bit to negative 10 degrees, and the deviation to negative 4 degrees. So by following the formula, 220 degrees, which is the compass course, minus 10 degrees of our variation, and minus 4 degrees of deviation is equal to 206 degrees, which is our true course. That will be all. Next, please. So this slide will be reported by Cadet Buliuzos.
Thank you for that, Cadet Manuel Erdonafe. So to continue our report, converting a true course into a compass course. Finding a course to steer, or CTS, is a little less straightforward, but it is still done with the same equation. Example 4. The true course drawn in the chart is 305 degrees and the local variation is positive 3 degrees, found in the nautical chart. Yet, we don't know the deviation. Compass course variation is equals to 3 degrees, deviation is unknown, true course is equals to 305 degrees. Luckily, we can rewrite this so this reads compass course plus deviation is equals to 305 degrees, true course negative plus 3 degrees variation is equals to 302 degrees. Example 5. The true course from the chart is 150 degrees and we have a western variation of 7 degrees or negative 7 degrees because the direction is to the west. We will use the rewritten equation to get compass course is unknown, variation is given negative 7 degrees west, deviation is unknown, true course is 150 degrees. So to solve this is 150 degrees times true course minus negative 7 degrees variation equals compass course plus deviation is equals to 157 degrees. From the deviation table, we find a compass course of 160 degrees with a deviation of negative 3 degrees. So the magnetic course. The magnetic course is the course after magnetic variation has been considered, but without compensation for magnetic deviation. This means that we are dealing with a rewritten equation from above. True course minus variation equals compass course plus deviation is equals to magnetic course or MC. Magnetic courses are used for three reasons. Number one, to convert a true course into a compass course like we saw in the last paragraph. Number two, on vessels with more than one steering compass, also more deviation table are in use. Hence, only a magnetic or true course is plotted in the chart. Bearings taken with a handled compass often don't require a correction for deviation and are therefore useful to plot in the chart as magnetic courses. So this slide will be reported by my co-groupmate Decadet Bongoyan Francis Rigi.
On to the glossary, which are the common terms that we use in our topic. So first is the variation. The angle between the magnetic North Pole and the geographic North Pole, also called the magnetic declination. Second is the circular variation. The change of the magnetic declination in the time with respect to both strength and direction of the Earth's magnetic field. View this declination or variation maps with isogonic lines, word interactive and historical declination, and an animated in time GIF. Next is the west-east. West variation or declinations as well as west deviations are designated with a negative sign by convention due to the compass card's clockwise direction. Deviation: the compass error caused by electrical currents or metal objects. Next is the deviation table. A table containing deviations in degrees versus the ship's heading or compass course in degrees, usually plotted in graph or card. Next is the true course. The true course corrected for compass errors and plotted in the chart. True course and is equal to course over ground or COG or course made good or CMG. Next is the compass course. The course which is corrected for both variations and deviations. Next is the magnetic course. Means the course which is only corrected for variation. And next is the compass course plus variation plus deviation is equals to true course. This equation shows the connection between the compass courses. Its error and true course. It can also be read as true course minus variations is equals to compass course plus deviation. That's all for our topic. Thanks for your attention and have a good day.